All right, this is Big Dog Sporting here, and today we have a Ford 4.9 inline six cylinder head. So this cylinder head received our stage two porting. It actually was completely rebuilt with new valve guide liners, some replacement valves, complete machine work, complete valve job, new seals, our stage two porting. It also received a 30-degree back cut on the intake valves, and all of the valves were reconditioned. The springs were also set up to increase the installed seat pressure. Now, this cylinder head came to us from a customer that sent it to us. I don't know if he knew or not how bad the cylinder head was. And we typically get that a lot. You know, customers will come to us and they'll say, well, I want stage two porting, which is our entry level porting. Basically, with the porting, you get a full intake and exhaust port, a full combustion chamber port, reshaping, you get before and after flow testing, you get spring checked and set up. Okay, you get a 3-angle valve seat cut. And in most instances, we also do a recondition on the valves themselves. We recut the valves. You get a valve lapping on valves that aren't being recut. If the valves are in good condition, we'll just go ahead and lap them into our new 3-angle valve seat cut. If not, we'll go ahead and recondition the valves too. And a cleaning, and before and after flow testing, like I said before, that's stage two. So that's the entry level. You get all that on our entry level stage two. This cylinder head was in pretty bad shape. I don't know if the customer knew about it, but it had some bent valves, and it also had some split valves. The valve seats were in terrible condition, and it was just pretty much beat up, you know. So as an example, here's one of the exhaust valves. As you see, that valve, this is how, the valve was. It was covered in crap, carbon and gunk, but when it was disassembled and cleaned, this is what we found. And some of the other valves were also bent, slightly bent. So I don't know how hard they was running this. I don't know if it was detonation heat or whatever, but it was in bad condition. And we went on ahead and notified the customer that we recommend, the head to have a full valve job and completely rebuilt, because it was in bad condition, and I didn't want to just do a port job on this, and of course you couldn't reassemble it with those valves like that. So we notified the customer and went on ahead and had it shipped out. This is an unusually heavy head, iron, and it's very long. So it was a lot of delays because we had to find, the machine shop had to find valves. They were behind. We used Windy City Machine Shop, which is one of the largest machine shops in the Midwest. They get a lot of volume with trucks and cars and fleet vehicles with, machine work. And throughout, the whole COVID and being backed up, and this head just got, delay after delay after delay after delay. And finally, we got the head together, finished porting it, got it all set up, and as you see, we're getting ready to flow it to show you guys. So we have it set up with the intake runner, and we're going to post the before and after flow results in the description of the video. So if you guys want to do a comparison of how it was before and then after, you can just view it there. So we're going to go ahead and set this up. Of course, we have, I don't know if you can see it back there, but you can see the spark plug. I have the spark plug in there to make sure. We have seen some people post flow videos and, you know, their flow numbers are extremely high. I mean, not even on the chart, they're off the chart. And usually that's a result of flowing a cylinder head without the spark plug in the back. Okay, so we want to show you guys that our flow techniques is the same and we don't have to fudge any numbers. We put a lot of work and time and testing into our work, and the numbers are what they are. For you guys that don't know, our flow bench calculates everything to 28 inches automatically, which allows us to flow parts very, very quickly when we're doing initial profiling of the cylinder head. But we also can adjust it to 28-inch depression as well. We usually don't do that because that takes extra time to have to cut on motors, cut motors off, adjust the valve, flow valve, or whatever, and the results don't change. You know, if we have time, I'll show you that in this video. The results really don't change. From 20 inches to 30 inches, you're talking about maybe a half a CFM difference, maybe. You know, so we tend to just, you know, flow them outright, but we will show you that in this video. So we're gonna go ahead and set this up for 100 thousandths of an inch. So that's 0 out and 100 thousandths. Okay, and then we're gonna set up the flow bench processor. Okay, and then we're gonna kick it on. So at 100 thousandths, kind of loud, 100 thousandths, I'm gonna adjust the valve for 28 inches. As you see, it takes time, and the flow really isn't changing as I adjust the depression. But that's 28 inches. You're looking at 77, 78 CFM. Okay, so for 200 thousandths, we're at 137. I'm going to adjust the depression. Didn't change. It's still about 138, 139. So 300 thousandths. Gonna pick on another motor. $300,000. That's 28 inches. It's about 180. $400,000. Going to adjust the depression. About 187, 188, 500,000. Adjust the pressure. About 192, 193. So now I'm going to crank the depression up. As you see, the processor adjusts the 192, 193. Crank it up some more. 31. Same thing, 192 and 193. So as you see, you got a chance to see what our stage 2 results were on this 4.9 inline 6 cylinder head on the intake. And you also got a chance to see in real time how our flow bench processor adjusts to calculate the depression or vacuum to 28 inches, no matter what you give it. You know, you saw the depression was 26, 25. It calculated to 28 inches, came up with the same number as when the depression was 31 inches. So it's funny because we love for the naysayers to say, oh, big dogs can't do this and big dogs can't do that. And we like that because it allows people to see what they're saying. Then we come back and we prove them wrong. And what that does, it pretty much builds, confidence in our customers and future customers. And it also, quiets the naysayers. For a long time, we've had, some of the naysayers say, well, you can't get this amount of flow, or you can't get these parts to do X, Y, Z. Then we'll go out there and we'll put up live videos, not just numbers, not just written numbers. We take the time to bolt on parts and flow them in a video and show you the raw data. They're not edited. We don't have a fancy, editing firm doing that. It's raw flow data. That way you guys can see the truth. And we're constantly proving these naysayers wrong. And I understand why the naysayers are the way they are. You have a lot of individuals that's been brainwashed over the years by, a certain group of individuals that want you to believe that certain parts are limited. So you either deal with them or you are forced to buy aftermarket, and maybe it's because those individuals simply can't get the results that, we've gotten with certain parts. Maybe it's they don't want to. Maybe they've gotten to the point where they don't care about maximizing parts or doing the best that they can. They just only care about fast turnaround so they can, generate a lot of revenue or generate revenue from individuals that just don't know any better. We understand that the customers don't have access to all of the equipment, all of the tools, and you guys rely on us to give you what you're hoping for. I understand that. This is Tony. I understand what the customers want because, years and years and years ago when I was a teenager, I was once a customer. I was once that individual that shopped around and I wanted certain things done and everybody told me either it can't be done, you have to buy this part that costs an extreme amount of money, or we're going to overcharge you for the bare bones minimum. And I told myself, I said, when, I started companies and, we got into this to other things, I said I was going to model our company on giving the most for the least. That way, everybody, not just those that have the resources or those that have deep pockets, but everybody can benefit from great port work and great products. And that's what we're bringing you. So, yeah, the naysayers, they don't like that. They don't want to see that. They don't want to hear that because it's cutting into their business or what they've been telling customers for decades, and it's making them look bad. So they're going to do everything they can to either say or spread lies and rumors. But as you saw our flow bench calculate the same result at different depression on this cylinder head. 28 inches, 31 inches, 20 inches, 25 inches. Doesn't matter. You know, you also saw me do something that we typically don't do. Well, we haven't done in, previous videos. And that's adjust the depression as I'm flowing. A lot of the naysayers didn't know that we had that capability. They don't know that we have 10 Amatec motors. A combination of 110 volt and 240 volt. So we can flow, a lot of parts at 28 inches, at a higher CFM. We just don't have to because, like you saw, our flow bench calculates to 28 inches. So why, crank up, 8, 9, 10 motors, pull all that power, create all that noise, create all that heat to get basically the same result. Now, if we are publishing something like Stan Weiss or whatever, then yeah, we'll flow it at 28 inches because that's industry standard, and, that way, you can see it at 28 inches, even though the result's going to be the same. But for our purposes and for our, video purposes, most of the time, it's not needed because the results is not going to change anyway. So you guys have seen that. So you can compare our before numbers to everybody else that has legitimate, flow benches that's accurate, because there's a lot of flow benches out there that's not accurate. One of the things that I hear a lot from a few guys that I know that own a Superflow 600, that you see it on their form, is the fact that they can be inaccurate for various reasons, because of a poor or bad calibration, because of the fact that they have different level nozzles that you can turn 1, 2, 3, 4, and that can alter the flow result. Ours can't do that. Ours self-calibrates. We can't change a different level on our flow bench to get a different reading. It pretty much has a built-in sensor that monitors the air, sort of like a map sensor, and it adjusts for the temperature, air density, and it adjusts for the pressure coming in. So we can't change it. We can't set it on level number 2 to get a higher flow result. That way we can publish higher numbers. We can't do that. It is what it is. It flows what it flows. And like I said before, you can compare our before numbers to accurate flow benches, and they're pretty much the same way. We also like to use fixed radiuses. These radiuses right here, they're fixed. They're fixed. These radiuses right here, they don't change. Okay. We've done a video, I don't think we published it yet, that we had a cylinder head bolted to the flow bench, and we used a clay radius. Okay, we made some clay radiuses out of, boom, Play-Doh, and we flowed that cylinder head at 500 thousandths of an inch. Okay, and we turned the flow bench off. We used the clay radius, and we flowed it, took a number. Okay, we turned the flow bench off, we took the clay radius out, put it back on with a slightly different shape, and flowed it again. We didn't change the calibration on the flow bench, and we didn't change the setting on the valve fixture. And with the different shape of the Play-Doh, the clay radius, it read a different CFM number. I believe it was up like 7 CFM, 6 or 7 CFM. So when we see individuals flowing with clay radiuses, and hundreds of people use a clay radius, and they flow before and after, or they give you an after flow, my question is, okay, if you introduce things that can create inconsistent measurements, then what is your true gains? Did you gain 25 CFM or did you gain 19 CFM? You know, that's a question that we like to eliminate by using the fixed radiuses. It's not perfect, of course. In some situations, you know, our fixed radiuses can actually not be ideal to a particular cylinder head. It may short it out 2 or 3, 4, 5 CFM, but it's doing it on both the before flow testing and the after. So it's consistent, and that's what we look for. We don't look for, hey, this cylinder head flowed 230 CFM for a GT40P. We look for from before to after, it picked up 35 CFM. We looked at the gains because the gains are universal. You can say, well, on your flow bench, it flowed 225 CFM, but the gains are still the gains. If it picked up 35 CFM, then it's going to pick up 35 CFM on any flow bench as long as they're flowed before and after on the same flow bench. So enough babble. This is a long video for us. So just letting you guys see, this is the flow of this inline 6 4.9. Here's the before numbers. This is the before numbers. Okay. Intake and exhaust. And we'll post the after numbers in the description. So once again, this is Tony over here at Big Dogs. See you guys at the track.